Hi guys, welcome to Let Us Learn YouTube channel. Today our session is about voltage divider rule and current divider rule. So here we are going to discuss two main concepts for solving the numerical problems. So in this, when two or more resistors are connected in series with a voltage source V, then the current I is given as I is equal to V total voltage divided by total resistance. Already we studied this concept. I is equal to V by R in Ohm's law. The same concept we are going to discuss. This V is the total voltage and R is the total resistance. Now we are going to discuss with a small example. So in this example, I am having R1, R2, R3. All are connected in series, and then the total current is I and total voltage is V. But the voltage across R1 is V1, the voltage across R2 is V2, and voltage across R3 is V3. So now from the figure 3, the total resistance R total is equal to R1 plus R2 plus R3. Already as we discussed in the DC series circuit, the total, to find the total resistance is equal to sum of all resistance, and total current I total is equal to V total by total resistance. Total resistance is R1 plus R2 plus R3. So here we substitute that value R1 plus R2 plus R3. Now the voltage across V1, the voltage across the V1 we are going to find. So voltage across V1, V is equal to IR, but I is the common, because in a DC series circuit the current will be remains constant, so the entire current will flow through all resistance. So V1 is equal to I into R1. So V1 is equal to, so instead of this V, I, we can substitute V by R. Instead of this I, that is the total current, we can substitute V by R total. So V1 is equal to V into R1 divided by R1 plus R2 plus R3. Therefore V1 is equal to total voltage into the voltage across the V1 resistance divided by total resistance. Again I am repeating the same concept. V1, just we are going to find the voltage across V1. So V1 is equal to total voltage into and the resistor across this V1, divided by total resistance R1 plus R2 plus R3. Similarly V2 is equal to total voltage into the voltage, the resistance across this voltage across the R2. So V2 is equal to V into R2 divided by R1 plus R2 plus R3. Similarly V3 is equal to V into R3 divided by R1 plus R2 plus R3. This is about the voltage divider rule. Now we are stepping into the current divider rule. So in this current divider rule, we are having two parallel resistors, R1 and R2 are the parallel resistors, and then total voltage is V and total current is I. Whenever the current is flowing in this branch, whenever it is coming to this junction or this node, it is divided into two branch. So in R1 resistors branch, the current which is flowing is I1, and in R2 resistors the current which is flowing is I2. But the total voltage will remain constant, because already we discussed in a parallel circuit the voltage will remain constant and current will divide. When two resistors R1 and R2 are connected in parallel, same voltage will appear across the both resistance. If you find the voltage across R2, if you find the voltage across R1 will be the same, which is equal to the applied voltage or supply voltage, because these two resistors are connected in parallel. The main concept for the parallel is the voltage will remain constant, the current will get different. Next, the total current I entering the combination divides into I1 and I2 as shown in the figure 4. So next, following this, we are going to discuss about the current divider rule. So in this, V is equal to I1 R1 and V is equal to I2 R2. So instead of this I1, if I am taking I1, I1 is equal to V by R1. Here also I2 is equal to V by R2. According to Ohm's law, V is equal to IR. So instead of this V, I am substituting I2 R2. Here I am substituting I1 R1. And then the I total is equal to I1 plus I2. So I1 I kept as it is, and I2, instead of I2 I am substituting I1 R1 divided by R2. I am taking I1 as a common. If I1 is common, 1 plus R1 divided by R2. If I am taking cross multiplication of this, so we will get I is equal to I1 into R1 plus R2 divided by R2. Therefore I1 is equal to total current into opposite resistance. See here, see, I have to clearly just note down here I1 current. While finding I1 current, total current into opposite resistance divided by total resistance. That is the formula. Similarly, I2 is equal to total current into opposite resistance. For I2, the opposite resistance is R1 divided by R1 plus R2. That's all. That is this we discussed today. So I hope you all enjoy this video, and then it will be very useful for any other exam, exclusively for VTU exam and other university also it will be useful. Please subscribe the video and hit the bell button. Thank you very much.